different kinds of chemical equations. So a molecular equation shows us the neutral formulas for all the compounds involved. But that doesn't really reflect what's happening in the beaker, right? We saw that when you have an aqueous solution of something like potassium nitrate, the potassium ions and the nitrate ions are actually separate. They're not together. So a complete ionic equation is going to show all of those aqueous ionic compounds, the soluble ionic compounds, as ions. So we're going to separate the aqueous ionic compounds. We are not going to separate anything that's a solid, a liquid, or a gas. So what we're doing is we're looking at the state symbols. If it's a solid or a liquid or a gas, you just copy it down as is. If it's an aqueous ionic compound, you separate it into the ions to make the complete ionic equation. Then what we'll notice when we do an example of this is that there are some ions that don't participate in the reaction. We call them spectator ions. They stand around and watch. Okay? They're not getting involved with anyone at the party, but they are watching lead and chloride. They're over there necking on the couch, right? Wow, they're really getting it on, right? So they're spectators. They're watching. They're not participating, okay? So we cross the spectators out to simplify the equation because lead and chloride, they would get together whether potassium was there or not, right? He's not really a participant, and so he's expendable. We could substitute somebody in for him. And what we do after we eliminate the spectators is we get a net ionic equation. This is only showing the things that are actually being changed, the things that are involved in the chemical reaction. When we say species, we use the word a little different than biologists do. Species just mean a kind or sort of thing. Here, that would be all the different molecules and ions. Species is easier to say than atoms, molecules, and ions. So it's just a thing. So this is a summary here. The molecular equation shows the complete formulas of all the compounds. The complete ionic equation shows all the species as they actually are present. So it'll show them as ions if they're dissolved, or full formulas, if they're solids. And the net ionic equation only shows the things that are participating. So let's do an example. Consider this reaction. And here we're given the balanced chemical equation, and we're asked to write a complete ionic equation and a net ionic equation. And on a test, I may just ask you, there's no we, I may just ask you for the net ionic equation, but you really kind of have to do the complete ionic equation so that you can get to the net ionic equation. So what we're going to do to write this complete ionic equation is we're going to look at state symbols. HBr, aqueous. Okay? This is an acid, but acids, when they dissolve in water, form ions. And so we're going to separate this into its ions. It's going to be hydrogen ion and bromide ion. So I'm going to write those down. You can save yourself a little time later by keeping track of how many of everything. So if I have 2 of these units, that means I have 2 hydrogen ions and 2 bromide ions. So I've got 2 hydrogen ions, and those are aqueous. And I have 2 bromide ions, and those are aqueous. Then I'm going to look at the next compound, calcium hydroxide. This is aqueous. I need to separate it into its ions. I've got calcium ion, and I have 2 hydroxide ions. So I've got calcium ion, aqueous, and I've got 2 hydroxide ions. And that's the end of the reactants. The first product is water. The state symbol here is L for liquid. This is not a soluble ionic compound. I'm not going to separate it into ions. So if it says L, G, or S, just write it down. Don't mess with it. So I'm just going to copy that down, 2H2O, in parentheses, lowercase l, and go on to the next one. This one has the state symbol AQ, so I want to separate it into ions. I've got calcium ion, and I've got bromide ion, and there's 2 bromide ions. So calcium. And if you haven't studied chapter 5 yet, you're going to have trouble with this, because you need to be able to write the correct charges and everything. There's my complete ionic equation. And the train chiming in. Okay, so if we want the net ionic equation, we're going to look for ions that didn't get changed. They are the same on the reactant side and the product side. So, you see any? Guys are all very quiet. How about bromide? There's 2 Br minus on the left side of the arrow and 2 Br minus on the right side of the arrow. Nothing happened to bromide. She's just watching. Okay, she's a spectator, so I'm going to cross her off. So maybe I'll use a different color. Cross off bromide. What else is a spectator? Calcium. Calcium occurs on both sides. Okay? To get the net ionic equation, then I'm just going to copy down what's left. So I've got 2H plus aqueous plus 2OH, I don't need parentheses, OH minus aqueous, and I've got 2H2O liquid, and that's all that's left. This is okay. It's a balanced equation, but it's not the best because there's a 2 in front of every species. We could simplify this. We'd like to have the lowest coefficients. So the best answer here would be H plus aqueous plus OH minus aqueous forming H2O liquid. I don't remember how picky Mastering Chemistry is about that stuff. I won't try to trick you with something like that. Now, I carried down the numbers here. You can do it without doing that. If that was confusing to you, you can just write down the ions, but then to have the complete balanced equation, the complete ionic equation, you're going to have to balance it and put some coefficients in there. And then when you get down here to the net ionic equation, you may have to balance it as well. Any questions?